I welcome you all to my YouTube lecture on languages and finite automata. So, what is a language? So, given an alphabet epsilon, so you can take that alphabet as any word or which can make a word or a string, okay, by concatenating the letters given in the epsilon. For example, the epsilon can be having 0, 1, or it can be having A, B, like that. So if we are concatenating x and y, we write it together as xy. An example, so as I told, it is 0, 1. So whatever the possible words over epsilon can be a finite string. Like 0, 0, 1, 1, like that you can have the words. It can be a combination of the letters given in the input alphabet. So language is a set of words. So we can have an empty string, that is epsilon. It is a unique string with 0 length. So it is actually empty string and it is a unique string. So we can concatenate two languages. For example, A into B will be having xy such that the x will be belonging to A and y will be belonging to B. So we can concatenate them and we can bring it as a new language. We can see some examples for a language. For example, L can be any x. So such that x is a bit string with 2 zeros. So whichever string is having 2 zeros, you can include in this language L. Second example, L equal to a power n, b power n, such that n belongs to a natural number. So you can have, for example, a power 2, b power 2 means that is one word, a, b, b. And you can also have like a power 4, b power 4. So these are all some words which are available in this particular language. Similarly, L equal to 1 power n, n is prime. So you can have like 1 power 3. So 1, 1, 1 or 1 power 5. So we can have 5 ones together. These strings form this language L. So hope you understood what is a language. So how to recognize this language? For example, if L is a language which belongs to S. Okay. So if there is a machine M, if it can recognize L, so that X is a string, it belongs to the given language. So when that string, input string is given to a machine M, that machine will accept that X string if and only if that particular string belongs to that language. If not, it will reject that particular input. So this is how we can recognize a language. So for this purpose only we need a machine called M. That machine is your finite automata. So finite automata is just a simple machine. It is not a list of words. So it will just read once. It will not write anything. So this machine cannot write anything. It will just read the input and it will tell whether the input is accepted by that machine or rejected by that machine. So it is having a very limited memory. So like for example, we can have like a cell phone or elevator door like that. Limited memory. For example, so you are having the automata like this, which is having a start state as Q1 and we are going to having 3 states Q1, Q2 and Q3. Okay, so we are showing in this state diagram for a given word, letter, which belongs to the string. Okay, for a given letter like 0 or 1, which state does that machine goes. So finally, the state will be some state, the machine will be in some state. We can consider that state as a accept or reject according to our problem or the language. So we can have some transition rules like when you are in Q1 state, if you give 1, it will go to Q2. Like that we can write the transition rules. So in this particular example, start state is Q1, accept state is Q2. So if you are giving an input 0, 1, 1, 0, first the machine goes from start from Q1. For the first input 0, it goes to Q1 itself. For second one, 1 it goes to Q2. For third one, it goes to Q2 itself. For the fourth, 0 goes to Q3. We can see that Q2 is the accept state, Q3 is not accept state. So automatically this machine will reject the given input. So consider this particular automaton. We have a input 101. So from Q1 state, when it finds 1, it goes to Q2. When it finds 0, it goes to Q3. Again 1, it comes back to Q2. So Q2 is the accept state here. So this particular input will be accepted by the machine, that is your automata. So here another example. From the given examples we can see that 0 1 0 is rejected, 1 1 is accepted, and 0 1 0 1 0 0 1 0 0 1 0 0 1 0 0 is accepted. On the whole, this is not only automaton to identify the strings with even length. So the strings with even length will be accepted. The string with odd length will be rejected. So if you are giving a null string, that will be rejected. So on the whole, we can define a finite automata as 5 tuple. Okay, it is a 5 tuple. First one is Q, that is a set of states. Second one is epsilon, that is the alphabet which is having the letters. Third one is a del, it is a transition function. This will be taking a function which takes input and a state and returns one state. Q naught, it is the start state, and F, it is a set of final states. We can have one or more final states. So this is how we can explain if you have an automata like this. Here we have the set of states Q as Q1, Q2, Q3, and the alphabet here is we are using only 0 and 1. The start state is Q, the accept state is Q2, and the transition function del we can define as the del using a transition table in the given manner. For each state Q1, Q2, Q3, and for each input symbol 0 and 1, we can write to which state it goes. For example, when you are in Q2 state and if you find a 1, it will be in Q2 state itself. So accordingly we write the transition table. So how to recognize this language? As I told, the machine will accept a word if and only if there is a sequence of states such that R0 is the initial state Q0. For the transitions, we will be having the transitions from starting from R1 for the next word till R plus 1. Finally, when you are in Rn state and if it is a final state, this particular string will be accepted. So whatever is the language recognized by a finite automata, we will call that language as a regular language and we will denote them as L of M. So a regular language is a language for which there exists a recognizing automata. So we can see vice versa. So any language which is accepted by a finite automata, we can recognize by finite automata is called a regular language, and a regular language can exist if it is having a finite automata. We have a concept called non-determinism where we cannot determine how to frame the rules. That is, for a particular input we cannot say whether it will go to Q2 state or Q3 state. This is called non-deterministic. So for example, if you have a automata like this, we can see that if there is a input 0 1 1 0, it will accept. So for 0 it goes to Q1, 1 Q2. Again we have 1. For instead of 0 it will take the epsilon in the middle. So Q3, 1 it goes to Q4, and 0 it goes again to Q4. So this is a accept state. So we are having a empty string in the middle. So these type of automata is called a non-deterministic automata. So for example, if you have a 1, so that 1 can only reach Q1 which is in a reject state, or it will go to Q2, or with epsilon it will go to Q3. All three states are reject state, so the string 1 will be rejected. So for any string, the non-deterministic is having a set of possible states. Final state is also having a set of accepting state, then it will accept the string. It is having the same format like your DFA, Q, epsilon, del, Q naught and F. So non-deterministic function is that it will be having the input symbol including epsilon. That is the difference between DFA and NFA. So recognizing language, same thing. If you are having a non-deterministic finite automata, it will accept a string only if it is satisfying the same three conditions. To start with start state, it will follow the transitions and end in the final state. So hope you understood what is finite automata. Thank you.